Okay, problem 25, sorry. Point B, D, and J are midpoints at the side of right triangle ACG. Point K, E, I are midpoints at the side of triangle JDG. If the dividing and shading processes are done 100 times, the first three as shown, and AC equals to CG equals to 6, then the total area of the shaded triangles is nearest to. So I'll just draw this again to give you better understanding of this problem. So we know side AC and CG are both 6, so this is side 6, and we know this side of the square hits the midpoint of this side, which is 6. Therefore, if it hits the midpoint, then each side is going to be 3. And since this and if this is 3, this hits the midpoint, and this is also 6, which means this must also be 3, and this must also be 3. Therefore, the area of this first square is going to be 3 times 3, which is equals to 9. But the shaded region is half of the square, so we need to divide it by 2, which means our first shaded area is going to be our shaded area of our first square is going to be 9/2. And our second square is going to hit the midpoint of this first square and the midpoint here. So the first square has a length of 3. If it hits the midpoint, then this much have a length of 1.5, and this must also have a length of 1.5. Therefore, the second area is going to be 1.5 times 1.5 over 2, which is equals to 9/8, and then so on. So if you repeat that process again, you get 9/32 plus 9/128 plus etc. And you see there's really no point calculating like all the hundreds or every 100 square, because it's going to get so small that it doesn't even matter to our answer anymore, because the answers are all integers. Therefore, we can just get an approximation of the answer, and we should be able to figure out which one it is. So 9/2, we don't even need this one actually too, because like 9/2 plus 9/8 plus 9/32 is going to be approximately 5.9, and we can see as we add more to it, it's going to get nearer to 6, which means our answer is going to be 6. It definitely will never reach 7. So this is a second solution, which is more accurate, but it might take a bit longer. So the second method uses a concept called geometric series. If you've never heard of it, I recommend you learn it before you learn the solution. So as we already determined, the area of the shaded regions are 9/2 plus 9/8 plus 9/32 plus 9/128 and so on. We can see that this forms a geometric sequence, and geometric sequences are in the formula of S equals to A1 over 1 minus r, where a1 is equals to the first term of the sequence and r is equals to the common ratio. Common ratio is basically the difference between the first and second terms, second and third, the difference between all the terms basically. So the first term is obviously 9/2, so we have s equals to 9/2 divided by 1 minus the common ratio. We can find the common ratio by dividing 9/8 by 9/2, and that's equals to 9/8 times 2/9 equals to 18/72, which is equals to 9/36 equals to 3/12, which is equals to 1/4. So common ratio is 1/4, so 1 minus 1/4. And simplifying this expression, we get 9/2 times 4/3, which gives us an answer of 6. So it's answer is choice A.